Today, we shall learn about the qualitative analysis of organic compound. How to detect that water is being formed? You're heating, water will be in the form of water vapor. Ferrous sulfate and then acidified with concentrated sulfuric acid. Two elements you can detect with one test, that is using AgX is the one which is giving the color to the precipitate. Hello my dear students, welcome back to session 7 on the chapter Some Basic Principles and Techniques of Organic Chemistry. Last class we studied about the distillation process, different types of distillation process, when do we have to use which distillation process we learnt. We also learnt about differential extraction process and we also learnt about different chromatography methods. Today we shall learn about the qualitative analysis of organic compound. When I tell qualitative analysis means I am finding out the quality of the organic compound. Now, when I tell organic compound, we know that basically organic compounds contain carbon and hydrogen. But other than carbon and hydrogen, it can contain elements like nitrogen, sulfur, halogens, phosphorus, oxygen, etc. Okay. So, not only carbon and hydrogen, they can be these elements. So, how are we going to find out, other than carbon and hydrogen, which element is present in a particular organic compound? For example, I can tell if there is a nitrile, okay, I have the R group with the nitrile group, it contains nitrogen, okay, or it can be an aldehyde group. When aldehyde is present, there is oxygen, carboxylic acid there is oxygen, ketone there is an oxygen. So, other than carbon and hydrogen, how are we going to detect which element is present? We learn, okay. First, we learn the detection of carbon and hydrogen. Here, the organic compound we take and heat it with copper oxide, okay. Copper oxide is CuO, where copper is in +2 state, oxygen is in -2 state. Now, what will happen when I heat the organic compound? The carbon which is present in organic compound will react with CuO, okay, to form copper will remain as it is, carbon with oxygen will combine to form carbon dioxide gas, and if hydrogen is present, it reacts with CuO to form water. So here, how do you detect that carbon dioxide only is produced? What we do is, we pass carbon dioxide through lime water. Lime water is calcium hydroxide solution, okay. So you take lime water, to that when you pass carbon dioxide, you get a white precipitate of calcium carbonate. So when you get that precipitate, you understand that carbon dioxide gas is liberated. Similarly, how to detect that water is being formed? You're heating, water will be in the form of water vapor, isn't it? So now water, okay, will go and combine with anhydrous copper sulfate, then the white color copper sulfate will turn blue color because it is taking up water of hydration, okay. So we'll understand this better using the diagram. So what we are doing here is, in this test tube we are taking organic compound and CuO, copper oxide, and heating it. See, we are heating it. Now what happens is, the carbon which is present in the organic compound reacts with CuO to form carbon dioxide. But we can't see carbon dioxide. So you can see that the test tube is fitted with a tube in which there is a bulb in which we have kept anhydrous copper sulfate, which is white color, and here the end of the tube is filled, or it is coming to lime water, that is CaOH twice, okay. Now what happens when I am heating, when carbon dioxide is passed, it just passes through, comes to lime water, and lime water will turn milky. So if lime water is turning milky, carbon dioxide is produced. Similarly, If hydrogen is present, it reacts with copper oxide to form water. Now water, whatever is formed, comes and it turns the anhydrous copper sulfate, which is white color, to blue color. So if this turns blue color, then we understand that water is produced. That means the organic compound has hydrogen. If lime water turns milky, then the organic compound contains carbon. Okay. So this is the method to detect carbon and hydrogen in organic compound. Next is detection of other elements other than carbon and hydrogen. How do we do this? This test is called as Lazaine's test, or we can also call as sodium fusion extract test. In this test, I can detect the presence of nitrogen, sulfur, halogen and phosphorus. Nitrogen, sulfur, halogens. Halogens means it can be chlorine, bromine or iodine. Okay, and phosphorus. All of these elements, if it is present, we can detect using Lazaine's test or sodium fusion extract test. Now what are we doing here? We take a small tube called as the sodium fusion tube. Okay, it is the smaller version of the test tube you can imagine. And we take a small piece of sodium metal. What is it? Small piece of sodium metal is added into the tube. To this, you add 3 to 4 drops or small amount of organic compound. Okay, whatever organic compound your solution is there, you can add to this and you have to heat it. Okay, you heat it to red hot. That means this tube will become red hot. Okay, meanwhile, you have to keep a china dish ready, okay, with distilled water. So you have water here. To this distilled water, when that becomes red hot, you will add into it. See, glass is red hot and you're suddenly putting it into cold water. What will happen? It will break. You're plunging the red hot sodium fusion extract tube into distilled water. Now, what you do is you heat this china dish again. Okay, so that you get a concentrated solution. Okay, and then the entire solution is cooled and filtered. Now the filtrate what you get is called as sodium fusion extract. Okay, now what is happening when you are heating your organic compound with the metal sodium? So you're taking sodium metal with organic compound, isn't it? So what is happening there? See, sodium, if carbon is present, it reacts with carbon and nitrogen to form sodium cyanide. Okay. Sodium with sulfur, it will form sodium sulphide, Na2S. And sodium with halogen, it will form sodium halide. So now, the elements other than hydrogen and carbon, if carbon is there, it is used here. But other than hydrogen, all of them are reacting with sodium metal to form sodium cyanide, sodium sulphide and sodium halide. Now, my sodium fusion extract contains this form of the element. Now, I have to detect whether there was nitrogen in my organic compound or sulfur or halogen in the organic compound using different tests. So, which are the tests to detect what is there in sodium fusion extract? Okay. First is test for nitrogen. So now my sodium fusion extract contains sodium cyanide if there was nitrogen in my organic compound. Correct? So the cyanide ions are there, okay, which contains the nitrogen atom. For this sodium fusion extract, we add ferrous sulfate and then acidified with concentrated sulfuric acid. So what you're adding? You're adding ferrous sulfate. Okay, so ferrous sulfate is FeSO4 which contains Fe plus 2 ions and you will get a Persian blue color. You get first ferrous cyanide. For that ferrous cyanide, excess of ferric ions you have to add. You get Persian blue color solution. So you're taking your sodium fusion extract, adding ferrous sulfate and then acidified with concentrated sulfuric acid. Formation of Persian blue color confirms the presence of nitrogen. So sodium fusion extract plus FeSO4 plus you add concentrated sulfuric acid. You will get Persian blue color. Okay. Then if you get Persian blue color, nitrogen is present. Okay. Next test is for sulfur. So how to detect whether sulfur is present? Now, sodium fusion extract you take sodium fusion extract. Okay. For this you add acetic acid. What is it? You add acetic acid and then lead acetate. If you get black color, then sulfur is present. Okay. So what is happening there is sulfide ions reacts with lead ions to form lead sulfide, which is black color. Okay. So this is one test. There is one more test for detection of sulfur, that is, now you take the sodium fusion extract and treat it with sodium nitroprusside, that is Na2FeCN5NO. This is sodium nitroprusside. Here the ionic form I have written, here the molecular form I have written. So sodium fusion extract plus sodium nitroprusside you add, you will get violet color. Okay. If you get violet color, then sulfur is present. Now, what is exactly happening is sodium nitroprusside is getting converted, or you can see NOS, what is this? Sulfur, what is there, is coming into the complex. That's why the color change you can observe. Now, for example, in my organic compound, nitrogen is also present, sulfur is also present. Okay, what is it? Nitrogen is also present, sulfur is also present. Then the sodium metal with carbon, nitrogen and sulfur can form sodium thiocyanate, SCN. That means sodium cyanide is not formed, sodium thiocyanate is formed, and thus what will happen is when you add ferrous sulfate, acidified ferrous sulfate, it will form blood red color and blue color we will not get. Now for nitrogen, only when nitrogen is present, what will happen? It will form NaCN. And for this one, when you add the ferrous sulfate solution, acidified ferrous sulfate solution, you will get blue color. But if sulfur is also present in the organic compound, you will not get blue color with acidified ferrous sulfate solution. You will get blood red color. So if you get blood red color, then you should think that not only nitrogen is present, sulfur is also present. So two elements you can detect with one test, that is using ferrous sulfate, which is acidified. Okay. So that's about the detection of sulfur and nitrogen. Next is test for halogens. Now the halogens which I can detect here is chlorine, bromine and iodine. Okay. So we take the sodium fusion extract and add dilute nitric acid and then silver nitrate solution. Okay. So when I add this, if I get white precipitate, then it is chlorine. If I get yellowish white precipitate, then it is bromine. If I get yellow precipitate, then it is iodine. And all the three precipitates have different nature when you treat it with ammonium hydroxide. What we will see here. So what I am doing here is, see, silver nitrate, when I add Ag plus with halogen, it will form AgX. And this AgX is the one which is giving the color to the precipitate. That's the precipitate which is formed. So what is happening? You take the lezines extract, I dilute nitric acid, add silver nitrate. If I get white precipitate and if it is soluble in ammonium hydroxide, then it is chloride ion. Chlorine is present. Okay. If I get granary yellow precipitate, that is off-white color, okay, precipitate if we get, and it is sparingly soluble in ammonium hydroxide solution. What is sparingly soluble? The precipitate is sparingly soluble in ammonium hydroxide solution, then it is bromine or bromide ion. Okay. Now, if I get a dark yellow precipitate and it is insoluble, the precipitate when you add ammonium hydroxide will not be solubilizing, then it is iodide. Okay. So, it is one test giving different color and different action with ammonium hydroxide. You get to know which halogen is present, whether it's chlorine, bromine or iodine. Okay. Next is detection of phosphorus. Now, how do I detect phosphorus? Compound containing phosphorus is heated with an oxidizing agent like sodium peroxide, which oxidizes phosphorus to phosphate. Okay. The solution is boiled with nitric acid and then treated with ammonium molybdate. Yellow coloration or precipitate indicates the presence of phosphorus. So what you're doing, you're taking your sodium fusion extract, treating it with nitric acid, HNO3 plus ammonium molybdate, Okay, if you get yellow precipitate, it indicates phosphorus. Okay, so you're taking sodium phosphate is there, add nitric acid, it forms phosphate group H3PO4. Further, add ammonium molybdate to the solution. Nitric acid is already there. You'll get ammonium phosphomolybdate, which is yellow color. Okay. So that's about the detection of phosphorus. Fine. Next is quantitative analysis. Till now, we learnt about the qualitative analysis. Quality. What is there in my organic compound, I detected. Now, for example, my organic compound contains carbon, hydrogen and chlorine. Then, next what I am going to do is quantitative analysis I will do. I will want to find out the quantity of carbon, quantity of hydrogen and quantity of chlorine which is present. So, qualitative analysis is Lezines test which we are using to find out whether there is nitrogen or oxygen or hydrogen or what is present, we will find out. But now next is quantitative analysis. So under that, first method is Liebig's method. It's a very important method for estimation of carbon and hydrogen. Now it's very important for me to estimate the carbon and hydrogen which is present in my organic compound. Here we are estimating in terms of percentage, and how we will learn here. Okay. In this method, we are taking the organic compound, and for example, my organic compound contains only carbon and hydrogen. This is just an example. Now, I'll pass oxygen, and carbon with oxygen will form carbon dioxide, hydrogen with oxygen will form water. Now, what is the amount of carbon dioxide formed and what is the amount of water formed, I should calculate. For this, we'll use the apparatus. Now, this is the combustion tube. Okay, it's the combustion tube. Here in the combustion tube, one end or opening is there for pure dry oxygen. I am passing pure dry oxygen, and here in the platinum boat the sample is taken. Platinum, because platinum does not react with oxygen, that's why we are using platinum container, okay, in which my organic compound sample is taken, and in this end it is sealed. It is sealed so that the oxygen will not pass outside from this end. So now, when the organic compound is heated with oxygen, what will happen? Whatever carbon is there gets converted to carbon dioxide, and whatever hydrogen is there get converted to water. Now, how do I find out the amount of carbon dioxide and water formed? To detect carbon dioxide in water, I had already explained you all the detection method. But here I have to find out what is the amount of carbon dioxide and what is the amount of water formed. So what we are doing is, at the end of the combustion tube, we can see there is a U tube in which there is anhydrous calcium chloride, and there is one more U tube in which there is potash. KOH solution is also called as potash solution. Okay. Now, before attaching these two U tubes, you can detach that and you can weigh the amount of anhydrous calcium chloride and weigh the amount of potash solution which is there in this tube. So what we do, we take this before the reaction, I'll weigh it, okay. I'll have to take the mass of this. So I'll take the weight of anhydrous calcium chloride and also I'll take the weight of potash solution in the U tube. Then I will attach, then we take the organic compound, pass oxygen, heat it. When carbon dioxide and water is formed, the carbon dioxide passes through this and it goes to this through the U tube. It will not react with calcium chloride. It will go to potash and it gets absorbed here. So the potash absorbs all the carbon dioxide which is formed. Okay. Now, water, what will happen? Whatever water is formed gets absorbed by anhydrous calcium chloride. It takes up all the water content which is produced by the organic compound. Now, after the test, okay, it is heated for a very long time at a high temperature in the furnace, so that all the organic compound, whatever carbon and hydrogen is there, that gets converted into carbon dioxide and water. Now, in the end, what we do is a gush of oxygen is passed, so that if there is any carbon dioxide and water which is trapped here, comes through, these two U tubes, and excess of oxygen is passed out. Okay. Now, once the experiment is done, it is completely cooled down. What we do is we take the U tube and we will weigh again. The difference in the weight gives us the difference in the weight of anhydrous calcium chloride gives us the amount or the mass of water which is formed, and the difference in the weight in the potash solution tube gives us the mass of carbon dioxide which is formed. Now, after the experiment, how do we do the calculation? Let us consider the mass of organic compound to be m grams. Okay. Then mass of water which is formed is m1 grams, mass of carbon dioxide is m2 grams we will consider. So how did I get this m1 and m2? I took the mass of anhydrous calcium chloride before the experiment and after the experiment. So whatever mass I got after the experiment, take that minus from before the experiment, the difference will give me the mass of water which is formed, that is m1 grams. The difference in the mass of potash bulb will give us the mass of carbon dioxide which is formed. Now, how do I calculate the percentage of carbon and hydrogen? I use this formula. Now, in carbon dioxide, okay, one molecule of carbon dioxide mass is 44 grams. That is 12 plus 32, 44 grams. Correct? Out of 44 grams, what is the mass of carbon? 12 grams. So, 44 grams of carbon dioxide if I take, 12 grams is carbon. Okay? Then, I have m grams of organic compound. So, what is the mass of carbon? 44 grams of carbon dioxide, 12 grams is carbon. Correct, no? So, we will take 12 divided by 44. In that, m grams of organic compound got converted to M2 grams of carbon dioxide. So I'll take M2 divided by M into 100. Or I can put it as 12 by 44 into mass of carbon dioxide by mass of organic compound into 100. This is percentage of carbon. Similarly, percentage of hydrogen, if you see, water, it got converted to water. So 18 grams of water contains 2 grams of hydrogen. H2O, mass is 18 grams, correct, no? Out of that, only 2 grams is from hydrogen. So we take it as 2 divided by 18 into mass of water by mass of organic compound into 100. That is nothing but 2 by 18 into M1 by M into 100. I'll get the percentage of hydrogen. You can either learn it directly like this, or you can learn the formula like this. It's left up to you. Okay. So this is the way we calculate the percentage of carbon and hydrogen in an organic compound. Next is, we'll do a numerical based on this Liebig's method. Okay. So we'll see, on complete combustion, 0.246 grams of an organic compound gave 0.198 grams of carbon dioxide and 0.1014 grams of water. Determine the percentage composition of carbon and hydrogen in the compound. So here you have to find out the percentage of carbon, percentage of hydrogen, given weight of organic compound or mass of organic compound is 0.246 grams. Okay. Carbon dioxide, weight of carbon dioxide is 0.198 grams, and water, weight of water H2O is 0.1014 grams. So now I have to use the formula. Percentage of carbon is equal to, first I need to write the formula. It is 12 by 44 into weight of carbon dioxide by weight of organic compound into 100. That is nothing but 12 by 44 into 0.198 divided by 0.246 into 100. So if I solve this, I'll get the answer as 21.95. So this is 21.95%. Okay. Same way, if I do or calculate the percentage of hydrogen. Percentage of hydrogen is equal to 2 by 18 into mass or weight of water by weight of organic compound into 100. That is nothing but 2 by 18 into weight of water is 0.1014 divided by 0.246 into 100, which is equal to 4.58%. Okay. So I hope you have understood how to solve the numerical. Okay. So next class we will be learning the estimation of nitrogen and estimation of halogens. Thank you, my dear children. Stay tuned, stay focused.